Hello, Paul. I just want to quickly go over what I've done with you. This won't take long at all. This is the model that I've been running. I already presented this before. This is my difference in difference model. And my results were interesting in that I found negative significant results for R1, which was acute respiratory illness. And I also found negative statistically significant results for C1, which are cardiovascular illnesses. I didn't find the same for R2, which are chronic respiratory illnesses. And that was expected after I did my residual analysis. However, I added synthetic control analysis to this just because the problem with small groups and different inference becomes uh, unreliable, and so it's good to complement it with synthetic controls. When I run the synthetic controls, I see that there is an effect for R1. This is the one that minimizes my root mean squared prediction error. And I find also interesting results for C1. And again, R2, chronic respiratory illnesses, is not as interesting. I don't see as much as an effect. The vertical line here indicates when the policy took place in Quito. Now, the fit isn't, it isn't perfect, but it is much better if I compare it to just the average of the other cities in Quito. I'm using 34 cities for my analysis, for my synthetic control analysis, and doing the synthetic control, or we can see it here in the graphs, doing the synthetic controls fits my line much better than if I just compare it to the average of all the other cities in Quito. This is looking at hospital admissions, and I'm running this on the residuals because the hospital admissions themselves were way too volatile for this type of analysis. So I took the residuals and I'm doing my synthetic control analysis on the residuals. So this is, again, these are just the synthetic control runs, and these are the donor pool average. And my synthetic controls fit much better than the averages do. For C1, it's not that far apart, but this difference here is because of the effect of the policy. So I am seeing an effect of the policy, but I want to see if this effect is robust. So I do some placebo runs. I do some in-time placebos where I change the timing of the policy, and I find that changing the time of the policy doesn't have any effect. So that's what I would expect. I also do placebo gaps and in-space placebos. I follow Abadi 2010, Abadi 2015, and their procedure. And I see here that even though, for example, this is for R1, acute respiratory illnesses, and I see even though there is somewhat of a gap, when I compare the blue line here to all the other gray lines, these are my placebo runs, I really see that for Quito, the fit is the best. It's one of the best, actually. So even though it appears to be far, um, like a big gap here, it's really not that big of a gap when I compare it to how my synthetic controls fits the other placebo cantons. Unfortunately, I go reducing the cantons that I compare to because in order to have this type of test, I need the fit to be good of the other cantons previous to treatment. But their fit is not good at all. So I follow Abadi 2010, and I eliminate the ones that have an RMSPE that are too large in comparison to Quito's. And then I'm left with about 5 or 6 cantons to compare with. But that's not a good comparison because it's not going to give me any assurance that what I'm seeing in Quito is rare, or it's out of, I can't say anything about the probabilities of having that result. And the same thing happens when I run these in-space placebo gaps for R2 and for C1. So instead of doing this, I look at another placebo experiment that is presented mainly in Abadi 2015. And what they do there is that they compare the post-intervention RMSPE to the pre-intervention, so it's a ratio. And what we expect is we would expect the treated unit, Quito, to have a very high ratio because the gap. So what we want, I'm going to go back here. We want this gap here, we want it to be large after treatment, and the fit to be very close before treatment. So we want the numerator to be large and the denominator to be small, and that's what we find over here. Actually, Quito is one of the highest with this post-pre root mean squared prediction error ratio. There's only 2 cantons that are higher than Quito, and so what that tells me, following the logic of the papers that I've read, is that if the treatment were randomly assigned to any of these cantons, the probability of having such a high ratio is about 8%. So that's given me, that can kind of be compared to a p-value. I'm finding some effect for R1 at the 8% level. I do the same. Oh, so these are there's 2 cantons here that also had strong effects. I look at them, they're Rocafuerte and Novol. But it's just that, that can happen. You see that. So it's not related to the policy at all. I do the same for R2. I don't find good results. Quito isn't one of the highest ones with the ratio. And I do the same for C1. And again, Quito's not a very high one. If you calculate the probabilities here, you're going to have about a 25% probability, a p-value of 25% kind of being able to find this result for Quito, for C1, for cardiovascular illnesses. Finally, just the last thing, I run another placebo test where I leave one out. And what that means is that I want to see how dependent my results are on the cities that are being used for the synthetic control. The red dashed line here is when I take out Cuenca. And then there's some light gray lines over here. Those are when I take the other ones out. And what I'm finding is that there is a dependency on Cuenca. The relationship really changes here when I take Cuenca out. But the change itself just means that, if anything, I'm underestimating the effect. I'm not overestimating it, because it becomes larger when I take Cuenca out. So that's a pretty good result for acute respiratory illness. But for R2, and surprisingly for C1, cardiovascular illness, the relationship really completely breaks down when I take Cuenca out. And what that means is that my results for cardiovascular illnesses that I found from the regression that are statistically significant, they really hinge upon using Cuenca as a comparison group. And when I take it out, I cannot say anything about the synthetic control effect, because without Cuenca, it's just not robust. So my conclusion is that for R1, I can be pretty sure that I am finding an effect, but for C1, even though my diff and diff was very significant, it's not as robust, and it's hard for me to conclude just from inference itself that that it's statistically significant. I can't discard it either. I just can't accept it. And that's I don't want to make this long at all, so that's going to be it for now. I hope you can take a look at this. Thank you.